Hello students, welcome to the lecture on linear and quadratic equations. And after this lecture, we will be able to learn the following objectives. Explain the characteristics of linear equations, understand the slope of a line and graph, determine the equation of a straight line, learn about linear equation involving two variables, understand quadratic equations. Let's start with the concept of linear and quadratic equations. A linear equation looks like any other equation. It is made up of two expressions set equal to each other. A linear equation is special because it has one or two variables. No variable in a linear equation is raised to a power greater than 1 or used as a denominator of a fraction. When you find pairs of values that make the linear equation true and plot those pairs on a coordinate grid, all of the points for any one equation lie on the same line. Linear equations graph as straight lines. A linear equation in n unknowns x1, x2 up to xn is an equation of the form a1 x1 plus a2 x2 plus up to plus an xn, which is equals to b, where a1, a2 up to an, b are given real numbers. For example, with x and y instead of x1 and x2, the linear equation 2x plus 3y equals to 6 describes the line passing through the points 3, 0 and 0, 2. Similarly, with x, y and z instead of x1, x2 and x3, the linear equation 2x plus 3y plus 4z equals to 12 describes the plane passing through the points 6, 0, 0, 0, 4, 0, 0, 0, 3. A system of m linear equations in n unknowns x1, x2 up to xn is a family of linear equations. Take a look at the screen. We wish to determine if such a system has a solution, that is to find out if there exists a number x1, x2 up to xn which satisfy each of the equations simultaneously. We say that the system is consistent if it has a solution, otherwise the system is called inconsistent. The matrix as seen on the screen is called the coefficient matrix of the system, while the matrix geometrically solving a system of linear equations in 2 or 3 unknowns is equivalent to determining whether or not a family of lines or planes has a common point of intersection. Example, solve the equation 2x plus 3y equals to 6. Solution, the equation 2x plus 3y equals to 6, which is equivalent to 2x equals to 6 minus 3y, or x equals to 3 minus 3 by 2y, where y is arbitrary. So there are infinitely many solutions. Let's look at another example. Solve the system. X plus y plus z equals to 1, x minus y plus z equals to 0. Solution, we subtract the second equation from the first to get 2y equals to 1 and y equals to half. Then x equals to y minus z equals to half minus z, where z is arbitrary. Again, there are infinitely many solutions. Now we will discuss the characteristics of linear equations. Y equals to ax plus bx to the power of 1, x cap 1, there are no exponents in the simplified formula. X is in the equation, so a does not equal b can be any number. Y equals to 5x minus 3. It forms a linear function, a line. y equals to 3x plus 2y minus 4x equals to 9. These are examples of linear equations, which is a first-degree algebraic expression with one, two or more variables equated to a constant. So, x equals to 2 is a linear equation, as is y equals to 1, but x2 equals to 1 is not, since the variable x has degree 2. The general form of a linear equation: ax plus by equals to c, where a and b are real numbers, not both 0. Often the general form is written so that the coefficient for x and y are integers, with the coefficient for x always being a positive integer. Horizontal lines. The equation of a horizontal line through a point AB is y equals to b. The coordinates of the y-intercept are 0, b. There is no x-intercept. Let us look at an example. Y equals to minus x plus 3. Y-intercept b equals to 3. That is, the graph of the line crosses the y-axis at the point 0, 3. Let's look at another example. Y equals to 2x. Y-intercept b equals to 0. That is, the graph of the line crosses the y-axis at the point 0, 0. Now moving on to the next topic, we will study the slope of a line. In layman's terms, the slope of a line is a measure of the steepness of the line. It is a ratio of the change in vertical distance over the change in horizontal distance as we travel from one point to another lying on the same line. The slope m of the line through the distant points x1, y1 and x2, y2 is calculated as shown on the screen. Regardless of the sign of the x-coordinate or the y-coordinate, the minus between the y values and the x values in the slope calculation must always be there. Slope and parallel lines. Two lines are parallel if they have the same slope. Slope and perpendicular lines. The slopes of perpendicular lines are negative reciprocals. Perpendicular lines intersect in a 90 angle. Slope and horizontal lines. The slope of horizontal lines is m equals to 0. Slope and vertical lines. Vertical lines do not have a slope. We say that their slope is undefined. Slope-intercept form of linear equation. Sometimes it is to our advantage to know the slope-intercept form of a linear equation. It is simply a special way of rearranging the terms in the general form. All you have to do is isolate the y variable on the left side. Y equals to mx plus b, where m is the slope of the line and b is the y-intercept of the line. Let us look at an example. 3x minus y equals to minus 1. Since we are given the general equation, we must first change it to the slope-intercept equation to find the requested information. Minus 1 equals to minus 3x minus 1. Y equals to 3x plus 1. Slope m equals to 3. Y-intercept b equals to 1. That is, the graph of the line crosses the y-axis at the point 0, 1. Point-slope form of a linear equation. Other times it is necessary to know the point-slope form of a linear equation. Specifically, we will use the point-slope form to find the equation of a line given at least 2 points on that line, 1 point on the line and its slope. Y minus y1 equals to m into x minus x1, where x1, y1, a point on the line and the slope is m. Regardless of the sign of the x-coordinate or the y-coordinate, the minus between the y values and the x values in the point slope equation must always be there. Let's look at an example. They have got a line with the slope 2. One of the points that the line passes through has got the coordinates 3 and 5. It's possible to write an equation relating x and y using the slope formula with the solution slope m equals to 2, point x1, y1 equals to 3 and 5. We know that x minus x1 equals to m into y minus y1. Let's know the meaning of graph. Representing a linear equation through a graph is called the graphing. If they have any linear equation, firstly we need to get the points which will be allocated on the graph. The characteristics of graphs of linear equations. As the name already implies, their picture must be a straight line. If the line is horizontal, it only has one y-intercept. If the line is vertical, it only has one x-intercept. If the line is oblique, neither vertical nor horizontal, it has both one x-intercept and one y-intercept, which may not be distinct. That is, the graphs of some linear equations cross the coordinate axis at the origin or 0, 0, which is then considered both the x and y intercept, the quadrants of rectangular axis. The rectangular axis divide the plane into 4 regions quadrant. By convention, the quadrants are numbered as 1, 2, 3, 4 in the anti-clockwise direction. Any point in the first quadrant will have both the coordinates positive. In the second quadrant, x coordinates are negative while y coordinates positive. In the third quadrant, x coordinates as well as the y coordinates both is negative. And in the fourth quadrant, x coordinate is positive while the y coordinate is negative. If you have 2 points, you can draw a straight line connecting them. So, if you have an equation in 2 variables and you know that equation is linear, which means its graph is a line, it is easy to graph it. All you need to do is find 2 ordered pair solutions, plot them and draw the line connecting them. Now let us look at an example. Graph the line y equals to minus 3x minus 6. Find the points at which the graph of the line crosses the x-axis, x-intercept when y equals to 0. 0 equals to minus 3x minus 6. 3x equals to minus 6, x equals to minus 2. The coordinates of the point at which the line crosses the x-axis are minus 2 and 0. Find the points at which the graph of the line crosses the y-axis, y-intercept when x equals to 0. Y equals to minus 3 into 0, minus 6 equals to minus 6. The coordinates of the point at which the line crosses the y-axis are 0 and minus 6. Coordinates of one additional point, arbitrarily choosing x equals to minus 4. Then y equals to minus 3 into minus 4 minus 6. Y equals to 12 minus 6. Y is equal to 6 and the coordinates of the additional point are minus 4 and 6. Horizontal and vertical lines. Equations of horizontal and vertical lines only have one variable. The equation x equals to 4 represents a vertical line which crosses the x-axis at the point 4, 0. Every ordered pair with 4 as its first coordinate is a solution. The equation means x is equal to 4 and y can be whatever it wants. Similarly, the equation y equals to minus 3 is a horizontal line which crosses the y-axis at 0 and minus 3. The point where the horizontal and vertical lines intersect is also easy to find. Example horizontal graph presentation. Do the following points. Lie on the graph of the line y equals to minus 3. Justify your answer algebraically. A, minus 3, 0, B, 0, minus 3. Solution. Step 1. Examine the graph. For the first point, minus 3 and 0, we find that the point minus 3 and 0 does not lie on the line. Y equals to minus 3. Step 2. For checking the point minus 3 and 0, algebraically substitute 0 for y. Y equals to minus 3. 0 is not equal to minus 3. In the given ordered pair minus 3 and 0, y is not equal to minus 3. Step 3. Examining the graph for the second point, 0 and minus 3. We find that the point 0 and minus 3 lies on the line y, which is equals to minus 3. Step 4. For checking the points 0 and minus 3, algebraically substitute minus 3 for y. Y equals to minus 3 equals to minus 3. In the given ordered pair 0 and minus 3, y equals to minus 3. There are 2 ways to determining the equation of a straight line. When the slope and a point is given and when 2 points are given. When the slope and a point is given, they are given m equals to 4 and point x1, y1 equals to 2 and minus 3. Solution. We know that y minus y1 equals to m into x minus x1. Y minus into minus 3 is equal to 4 into x minus 2. Equation is y minus 4x equals to minus 11. When 2 points are given, x1, y1, x2, y2, then the equation is y minus y1 equals to y2 minus y1 by x2 minus x1 into x minus x1, where y2 minus y1 by x2 minus x1 is equal to m. Then y minus y1 equal to m into x minus x1. Linear equation involving 2 variables. A study of linear equations can be solved 4 different ways: substitution, elimination, matrices, graphing. The method of substitution. Example, solution. Step 1, solve for y in equation 1. Step 2, substitute this value for y in equation 2. This will change equation 2 to an equation with just one variable x. Step 3, solve for x in the translated equation 2. Step 4, substitute this value of x in the y equation you obtained in step 1. Step 5. Check your answers by substituting the values of x and y in each of the original equations. If after the substitution the left side of the equation equals to the right side of the equation, you know that your answers are correct. The method of elimination. The process of elimination involves 5 steps. In a 2-variable problem, rewrite the equations so that when the equations are added, one of the variable is eliminated and then solve for the remaining variable. Step 1. Change equation 1 by multiplying equation 1 by minus $0.09 to obtain a new and equivalent equation 1. Step 2. Add new equation 1 to equation 2 to obtain equation 3. Step 3. Substitute y equals to 5000 in equation 1 and solve for x. Step 4. Check your answers on equation 2. The method of matrices. This method is essentially a shortcut for the method of elimination. Rewrite equations 1 and 2 without the variables and operators. The left column contains the coefficients of the x's, the middle column contains the coefficients of the y's, and the right column contains the constants. The method of graphing. In this method, solve for y in each equation and graph both. The point of intersection is the solution. Quadratic equations. A quadratic equation is one which must contain terms involving x2, example 3x2 minus 5x2, or x2 on its own. It may also contain terms involving x, example 5x or minus 7x or 0.5x. It can also have constant terms. These are numbers 6, minus 7, half. It cannot have terms involving higher powers of x like x3. It cannot have terms like 1 by x in it. In general, quadratic equations will take the form ax2 plus bx plus c equals to 0. A can be any number excluding 0, b and c can be any numbers including 0. If b or c is 0, then these terms will not appear. Solving of quadratic equations. There are 3 ways to solve quadratic equations: completing the square, factoring. Completing the square. Find the value to add to x2 plus 8x to make it become a square trinomial. x2 plus 8x. Multiply the coefficient of the x term by half. Square that result. So 16 must be added to x2 plus 8x to make it a square trinomial. Finding the value that makes a quadratic become a square trinomial is called completing the square. That square trinomial then can be solved easily by factoring. Now in the end, let us summarize what we have learned in this lecture. A linear equation looks like any other equation. It is made up of 2 expressions set equal to each other. Geometrically solving a system of linear equations in 2 or 3 unknowns is equivalent to determining whether or not a family of lines or planes has a common point of intersection. The slope m of the line through the distinct points x1, y1 and x2 and y2 is calculated. Methods of matrices is essentially a shortcut for the method of elimination. In a two-variable problem, rewrite the equations so that when the equations are added, one of the variables is eliminated and then solve for the remaining variable.